Okay, so now that you have learned where the general solution equations come from for our trig equations, let's do some examples. So you will need to memorize each of these equations, know the difference between your sines and your cosines, and be very careful. So let's take a look at our first example. Here we've got 2 cosine theta plus 3 equals 2. So the very first step in solving a trig equation is just what you would expect, is to isolate the trig function. So let's get cosine theta by itself. So we'll start by subtracting 3 from both sides. We can then divide by 2 on both sides. And so now we've gotten our cosine theta by itself. We can see cosine theta is -1/2. All right, so that gets us part of the way, but then let's rewrite it as theta by itself. So we'll just take the inverse of both sides. So we can say, okay, then theta is the angle whose cosine is -1/2. Now this is a unit circle value. Remember, for cosine, your principal values are in quadrants 1 and 2. Since this is negative, we're going to be in quadrant 2. So our principal value here is going to be 2 pi over 3. All right, so now we're thinking about coming up with our general solution equations. So for each problem, we're always going to be finding our general solution equations. There will be 1 or 2, sometimes more, and then we're going to find particular solutions. So the general solutions will involve an n, and the particular solutions will be sort of like your final answers. All right, so now we're going to come up with our general solution equation. So you're going to look at that pink sheet from the video, the very back of your notes packet. And what we're looking for here for our cosine equations, we're looking for our principal value plus 2 pi n and negative principal value plus 2 pi n. Notice these are just for cosine. Okay, so our principal value here is 2 pi over 3. So our first equation is just going to be principal value, 2 pi over 3, plus 2 pi n. Okay, got it. Now our second equation, negative principal value, so negative 2 pi over 3. Again, plus 2 pi n. All right, so those are our general solutions. We're done with step 3. Now we need to come up with our particular solutions within the specified domain. Okay, so what we'll do for that, and it says make a table, and I do require this, what we'll do for that is we're going to substitute n values into these two equations, and n is always an integer value. We're going to substitute those in and find as many possible final answers as we can. We're just going to stop when we get negative, and we're going to stop when we get too big, bigger than 2 pi. So I like to kind of keep in mind what my stopping point is going to be. So I'm going to think about 2 pi in terms of this common denominator fraction. Okay, so 2 pi is going to be the same thing, or 2 pi n is going to be the same thing as what over 3? So think about that for a second. All right, hopefully you said 6 pi n over 3. Those are equivalent fractions. All right, so we're going to stop once our values get bigger than 6 pi over 3. Okay, so when n is 0, if you plug in 0 here and 0 here, we're just going to have our principal value and, for our second equation, our negative principal value. All right, so we have 2 pi over 3 from the first equation and negative 2 pi over 3 from the second equation. Great. Now we need to come up with more solutions because there might be more between 0 and 2 pi. So to get there, we're going to add and subtract this 2 pi to our answer. And so you might be thinking, well, if I have a positive number and I'm adding 2 pi to it, because I'm saying when n is 1, I'm going to add 2 pi times 1, well, that's going to be bigger than 2 pi. If you recognize that and you know you're not going to have a bigger value here, that's great. Otherwise, add it. And what I like to do is I add that common denominator fraction, makes it a little bit easier. So each time I'm going to be adding 6 pi over 3. Okay? So when n is 1, I'm adding 1 2 pi, or 1 6 pi over 3. When n is 2, I'm going to add it again, another 2 pi, to my recent answer. All right, so when n is 1, I'm going to add 6 pi over 3, and I get 8 pi over 3. When n is 2, I'm going to add another, and I get 14 pi over 3. All right, And I could keep on going, but I've already noticed that I am way beyond my 6 pi over 3. So I know that I don't have anything bigger within this specified domain. All right, so now let me check on any smaller values. Okay, when n is 0, I'm here. So if I plug in -1 in for n here, what I'm doing is I'm subtracting 2 pi. Or, in terms of the common denominator fraction, I'm subtracting 6 pi over 3. All right, so 2 pi over 3 minus 6 pi over 3, that's where I get the -4 pi over 3. But I can't have any negatives because this domain says I need to be between 0 and 2 pi, so nothing negative. So that one won't work. So far we've got a bunch of answers that we don't even need. So we can get rid of the negative, we can get rid of anything bigger than 6 pi over 3. All right, that's from our first equation. Our first equation only generated one particular solution. Now let's go to the second equation. Here we already have -2 pi over 3, so let's think about if we subtract another 2 pi, we're just getting more negative. So we don't even need to really think about that, right? We don't need to actually do that because we know we can't have negatives. If your initial one is negative, subtracting is going to just make you more negative. All right, so now let's try finding the next value up. We're going to add 6 pi over 3 because we're adding 2 pi when n is 1 to our initial answer. All right, so -2 pi over 3 plus 6 pi over 3 is going to give us 4 pi over 3. Okay, so let's double check 4 pi over 3. Yep, it's less than 6 pi over 3. Great, it's still within our domain. Okay, if you weren't sure, if you hadn't thought about it, we have a positive, we're going to add 2 pi. It's going to be bigger than 2 pi, but just in case, you can add another 6 pi over 3, you get 10 pi over 3, but that as well is bigger than 6 pi over 3. You could, of course, keep on going until you run out of space within the domain. Okay, so now let's take a look. We don't need anything negative because that does not fit here. It has to be bigger than 0. And the 10 pi over 3 was also too big. So all of that work got us to narrow down our particular solutions within 0 to 2 pi. We've got 2 pi over 3 and 4 pi over 3. Those are our two particular solutions. So when you write your particular solutions, you can't just box them inside the table. You're just going to rewrite them, and usually we'll use our set notation. So we're going to say, okay, our particular solutions, our theta is 2 pi over 3 and 4 pi over 3. All right, so now you have found the general solution equations, our theta 1 and theta 2 here, for our trig equation. And then we found all of the possible particular solutions, the final answers, for the values that lie between 0 and 2 pi. You can see here from the table that there are infinitely many actual particular solutions, so that's why we have to restrict the domain and only find a select few.